Now in a previous video, we defined what a function of x actually represents, and we determined that this graph here of x equals y squared take 1 is not a function of x by using our vertical line test. But what if you're not actually given the graph itself and you've just been given the equation? You want to do an algebraic test to see whether this can be written as a function of x. Well, at the moment, as it's written, it's actually being written as a function of y, where we could actually rewrite this to be the function of y is equal to y squared take 1. But we're not interested in the function of y, we're actually interested in the function of x. So one way we can tackle this is to look at this equation that we've got here and see whether we can solve this for y. Now, if we were to solve this for y, we'd have to start by adding 1 to both sides. So x plus 1 should equal y squared. And then from here, we've got to remember that when we've got y squared and we want to solve for that, we've got to square root both sides. But the square root has two solutions. It has a positive solution and it has a negative solution. So I'm going to square root both sides here, and I'm just going to switch it around. So this will end up being y equals, and it'll be the positive solution here. So the square root of x plus 1, or the negative solution of it. So the negative of square root of x plus 1. Now it's sort of at this point that we can show that this cannot be written as a function of x. And to test this, let's actually substitute in some values here for my x. So what I'm going to do here is I'm going to look at what happens if x is equal to 3. Well, we've got to substitute this into both of these. So our y could equal the square root of 3 plus 1, which would be equal to the square root of 4, the positive square of that square root. So therefore my y could equal positive 2. Now if this was my line of x equals 3, that solution here is that positive 2 solution just here. But if we were to also substitute x equals 3 into my negative solution of it, well, my y will equal the negative of the square root of 3 plus 1, which is the negative of the square root of 4. So my y can have the solution of negative 2, which if we look at my graph, that vertical line here is located just here. So what we've essentially shown right now is, if we look at my table of x and y, when we put the value of 2 in for my x, it actually has two different solutions to my y. It doesn't have one solution to my y. And what I've in essence shown here algebraically is there is more than one solution that you can achieve for one input of x. And that means that you cannot write this as a function of x.